Okay, good day. On behalf of everybody of us who are involved in this study, I would thank the organizing committee for asking us to say a few words on our research. It will be a short report on what we are doing here at Tygerhoek, although the study is done over a whole range of sites in the Western Cape. I'm going to follow the normal procedures of telling you why we do it and what we do and what the results will be and our way forward, and also acknowledge who is acknowledgeable in this study. So I think what is important is that we must realize the past few decades, the face of the crop production in the Western Cape has changed quite a lot from where the soil was tilled up to no carbon left in the soil. It changed to where a lot of stubble is left on the soil surface, the soil is not disturbed, and this caused a lot of changes within the soil. And a figure that I normally use is this one about organic matter, organic carbon. Organic carbon is where everything starts, and one of my colleagues, or two of them, Professor Hardy and Dr. Johan Strauss, in their long-term studies, they found that the carbon content increased over time. And you can see it's clearly that within 10 years at this site, all the different systems resulted in an increase in carbon content. Now, the increase in carbon content will also result in an increase in aggregate stability, and that means that the soil becomes more crumbed. The aeration of the soil is good. Here you can see when the soil is conventionally tilled, the aggregate stability decreases, and there is consequences related to that. Important, the microbial activity changes, and that is if the carbon content changes and the aggregate stability changes, the microbial activity and diversity changes, and that is where the soil life starts. So if the microbes becomes active and they become diverse, that is really what we are looking at, and that will also influence the nitrogen relations within the soil. So, and with this, better crop production practices, better planters, improved cultivars, better soil fertilizer formulations, we have to look at our tillage, at our soil nitrogen application to our wheat crops. So there is already guidelines available from the Fertilizer Society of South Africa, and it is widely used, but it derives from information which was related to stubble fields, cultivation with tines, and wheat monoculture. Through the years, the people has adapted this and incorporated the possibility, the increase in carbon content and the increase in nitrogen availability. But the aim of this study was to look at calibration of this soils in the Western Cape again, to see if the old calibration curves still remains the same, or should we adapt due to the increase in carbon content and all the other changes within the soil system. There is a lot of people that worked on this in the past. A very important one was Johan van Biljon. They worked in the Free State, and they could have used a lot of different models to predict if there's a certain amount of nitrogen in the soil, you have to apply so much nitrogen to get to a certain potential. And that was one of the ideas when we started this trial, to see if we can relate soil nitrogen with nitrogen fertilization program. But the challenges in the Western Cape is when you look at our area, the yield potential varies quite a lot. Even within a camp, you have high and lower potential areas. It's not like the Free State where you've got large areas of uniform soil conditions, etc., etc. So it makes it very difficult. And then also when you look at our soils, it is quite different. If you look at the Swartland soil, Langewens, carbon content, this is to a depth of 30 centimeters, 0.8%. The Tygerhoek soil, 1.28, and then Darling sandy soils, and then Porterville intermediate soil. So it's quite a whole range of soils that needs to be addressed when we do this research. Okay, the soils here at Tygerhoek is shale-derived soils, which contains a lot of stones, and this makes it very difficult for us to get to nitrogen fertilization norms. So when looking at this soil, you can see that root penetration is up to about 40-50 centimeters, and we only sample the top 30 centimeters. So we determine in the soil the nitrogen content in this part of the soil, but we have the situation that the bottom part, there's also some roots, and we can't, with the system that we have, sample up to that depth. So that makes us a problem for us to get to the situation where we can say this is the profile available nitrogen. We only can say this is the nitrogen available in the top part of the soil. And then we decided to look at different sites where we will do the nitrogen study. It was Riversdale, here at Tygerhoek, Caledon, Darling, Langewens, and then Porterville. That is the 6 sites where we then do the studies. And I'm just going to concentrate on one part, and that will be the wheat after canola here at Rivier End. But all other sites we have at Caledon, for instance, wheat after Lucerne. We also have sites where we look at wheat after Medics. And as I've said, I'm going to concentrate on the Tygerhoek site. So what we are doing is we've got a control where no nitrogen is applied at all. Right through the growing season, only a foliar application at flag leaf stage. And then the rest is where we apply 25 kilograms of nitrogen at plant, and then different rates of nitrogen top dress from 0 to 165, and then also either with or without the foliar application. I'm not going to go into very detail about the statistics, but it's a randomized crop design with 4 reps. We are now in the 5th year, and we plant with no-till planters. Where we apply 25 kilograms in at plant, we apply, when we use a tine planter, 15 kilograms beneath the tine, and if we use a disc planter, only 5 kilograms of nitrogen with the seed. The rest is broadcast on the plot. We top dress, we try to postpone it as late as possible, more towards the 6-leaf stage, and our crop management is according to practices in the areas, and we harvest it with a small combine. So I think the data that we achieve is quite good. We are in an unfortunate position that we didn't really have good years. 2016 here at Tygerhoek was okay. 2017, 18 and 19, the rain was less than the long-term average of Rivier End. And what is also important is if you look at the long-term April-May rain, we are in an area or in a zone where the rainfall is much less than we are used to in this area. So what we do is then for the 5 years, I've got a a control treatment. So this is where no nitrogen was applied, and then it's 25 up to 165, and which was top dressed, and this is the years 2016, 17, 16, 17, 18, 19. What is important here is we see there is a reaction to nitrogen up to about 25 to 50 kilograms applied, but it's very difficult to get a norm from this. So what we then do is we calculate the relative yield. So what we do, we take the maximum yield of a year and we express the rest of the yields achieved with the different application rates to that, and then you've got something more, I can say, usable in a practical situation. So what actually happens is mostly people, or the industry, want to produce more or less at 90% of potential. So in this case at Tygerhoek, it should be here just over 50 to 60 kilograms of nitrogen. But I also want to emphasize here, look at this, where no nitrogen is applied at all. The yield potential is almost 60% and higher, which is relatively high. So a farmer can either decide to produce at 80% of potential, 90%, but almost never at 100%. It never makes economic sense to try and produce there. So the aim of the study initially was to try to get a soil instrument to be able to assist with developing the nitrogen norms. So I've got the relative yield again there. We took soil samples after top dressing to a depth of 300 millimeters, and this was the inorganic nitrogen content, that is the ammonium plus the nitrate. So, and you can see at 90%, the nitrogen content of the soil is about between 40 and 60. This is milligram per kilogram, so you still have to work in the bulk density of the soil, and you also have to work in the stone content of the soil. So this makes this soil, or this calculation, really a difficult thing, and I'm still in the process of trying to solve the problem of what is the active part of the soil, because we believe carbon will also play a role in this. Then, if you are producing, say, if you have a soil analysis of, say, 40 milligram per kilogram, but you need to push it up to 60, we can, with this calibration of this linear regressions, calculate the amount of nitrogen applied. So if you want to increase from 40 to 60, there is a way of determining with this linear regressions how much nitrogen must be applied to push the nitrogen to that required level in the soil. But it's very difficult, because look at this situation. The inorganic soil nitrogen content in 2016 was 27.34 milligram per kilogram. 2017, it was 68.73. 2018, 31.73. And 2019, 18.46. So you cannot just guess that this is the amount of nitrogen that will be there. So you actually have to go and determine how much nitrogen is there at plant. It will assist you in making the final calculations. And I think it's very important that you have to manage this thing also through the season. You can't start with saying, I'm going to apply 80 at plant. There is seasonal effects that might affect your decision of how much nitrogen to apply towards to get the optimum economical yield. Another thing which this study can enable us is to look at, there's your nitrogen at plant again, and this is the amount of nitrogen in the control plot, which didn't receive any nitrogen, and that is after top dressing. So in 2016, we could see that there was some mineralization because the plants absorbed nitrogen during that first about 10 to 12 weeks, and there was still more nitrogen in that soil than compared to the start of the season. 2017 was the vice versa one. 2018, again, there was more nitrogen in the soil after top dressing. In the period after top dressing, but it is a zero nitrogen soil treatments, and 2019 as well. So what this tells us, that there is some mineralization of this, and this is a wheat after canola system. There is some mineralization of nitrogen because there's more nitrogen after top dressing in the zero nitrogen plots compared to before planting. Then there's also a question from farmers when we started this trial, what is the effect of applying, why can't we apply just all nitrogen at plant? And what we've done is we applied in this area, the recommendation was 78 kilograms of nitrogen. So what we've done is 2019, LAN produced the best yields, but at plant was very close to it. All in at plant, 2018 was the best, and then 2016 again. So it can work to apply all nitrogen at plant, but I myself is not a great fan of propagating that. Then the way forward, so we've got all these data sets available, what to do with that. So one thing which is interesting, if I go back to the yield curves, and I look back at the tables that FITASA gives us, they say if you want a yield potential of 1,9 tons per hectare in this area, 300 millimeters rainfall, which would be about 180 in-season rainfall. They recommend a 45 to 55 kilogram in per hectare rate, and that is what we achieved. If, according to their tables, you want to achieve a yield of 2,75 tons per hectare, a little bit more rain, then you should apply 70 to 75 kilograms per hectare. So when we look at this, it seems that you have to apply much less to get to similar yields. But this is not the end of the story. If you look at the protein content of the seed, of the grain, then at 0, you are more or less at 10%, which is very dangerous. I think we want to be here at the 12% protein content. So lower levels of nitrogen, you're getting at a rate at a zone where degrading can be possible. The hectoliter mass is not really a problem because there's a decrease in hectoliter mass as the rate of nitrogen top dress increased. And then we also look at the 1,000 kernel mass. It's the same situation, but I can just say the reduction here can also be because we have, in most cases, not as good September rains as generally experienced in the previous decade or so. And then we also look at flag leaf nitrogen content. We want a value of, I think the recommended value is about 4.25. So we can see at the low levels of nitrogen, especially in this year, 2016, it was low, but a very slight increase in nitrogen content of the flag leaf. And that is a very important leaf in terms of yield. So I just want to also recognize the people that sponsored this: Sasol Agricultural Trust, the Winter Cereal Trust, the Stellenbosch University is working closely together with us. They've got students working on the trials, and then the Protein Research Foundation also give bursary to some of the students, and then the Western Cape Agricultural Research Trust.